This combination of lenses, which are used here, is a short focal length in reverse position, which generates high magnification, and a long focal length in ordinary orientation, where the short focal length is taking an in-between image and magnifies it by factor 6, 7, 8, depending on the focal length, depending on the rings. Means the 50 mm focal length is multiplied by the reverse part by 6, for example, in this application, means this set has a focal length of 300 mm, and the diameter and the length is very compact, and you can disassemble it later after you test and you have standard products. So it's a very flexible system. Now we measure the object distance, which is 16 centimeter. So this is a long distance macro setup from a combination of standard products using a wide angle lens in reverse position and a longer focal length in the front in ordinary orientation, and using distance rings to achieve that this in-between image is at the correct position, so that everything is in focus for each lens. This is now a distance of 60 centimeter, 61 centimeter high, and the result so that is normal orientation 12 millimeter. So in this setting I am using a 12 millimeter wider angle lens in the ordinary orientation. I have a short distance of 61 centimeter to the object, and I'm grabbing now the picture as reference. So in this setup I'm down to 16 centimeter object distance, just as a reference to following other settings, and for reference I'm saving a picture. 12 millimeter lens in ordinary orientation. So in this setting I try to go as close as possible to my object, and it's now shadowing already the PCB, so that the illumination has problems to reach the parts, and this distance is less than a centimeter. It looks like half a centimeter distance, 5 millimeter object distance. So this is the closest I can achieve with the V series lens with this very long thread, which makes it very attractive for this kind of application with microscopy. And this is the highest magnification with the 12 millimeter lens. And now I will show you how we can improve this. Now we try a special setting where we put the lens in reverse orientation on the camera using a filter thread adapter for C-mount. We put this filter thread on the lens and then have C-mount on this side, on the front side of the lens with the C-mount, and we put this in this orientation to the camera. So in this setting the lens is fixed on the camera in reverse position. The object distance is around about 17 millimeter and can only be focused by closing it more up or giving distance. So you find the position by correcting the distance, and the magnification is compared to the normal orientation, let's say 6 times bigger minimum. Using additional close-up rings in the reverse mode is showing up even higher magnification than using it in ordinary way without rings. So I tried sometimes 6 centimeter, got closer, and had a magnification like 6:9 to 1.